Pre-calculus L6 multiply 2 matrices. If you recall, in L2, we learned when we can and when we cannot multiply matrices. So remember, the dimensions of a matrix is rows by columns and rows by columns. So if the column of the first matrix and the row of the second matrix are the same, then that means that it is defined, and the answer, whenever we multiply them together, is going to be an A by C matrix. I'm going to pause just a second and get a different pen. Okay, let's try this pen a little bit better. Okay, so if D is a matrix of 3, -4, and E is a matrix of 4, 2, what is DE? And since we have DE right next to each other, it's asking us to multiply. But before we multiply, we have to determine whether we can or not. So the matrix for D, the size of D, is a 2 by 1, and the matrix of E is a 1 by 2. And since these numbers are the same, it is defined, and the size of the answer is going to be a 2 by 2. So we would push the 2 by 2 button, and it's going to give us this with 4 boxes to be able to fill in. All right, so now we have to go through how we are going to multiply these. And so let's change colors. And I have this matrix, and multiplying matrices is not commutative, which means you cannot put the second one first or the first one last. Okay, now let's get some colors. So if this is rows and columns, and this is rows and columns, well, the columns of the first and the rows of the second canceled out. We are only going to use the rows of the first matrix and the columns of the second matrix. This is row 1, row 2. This is column 1 and column 2. Now for our answer, we're going to have 2 rows. Probably should have put all of that in different colors. Let me back up just a second. I'm still going to say the same words, but I want to use different colors. Take all of that green off. Okay, so row 1, row 1, row 2. This, and what I'm doing seems a whole lot harder than what it actually is, okay? And this is column 1. And this is column 2. Okay, so what we're going to do, we're going to multiply the first element in row 1 to the first element in column 1. See where this green and purple collide? So we're going to do row 1 and column 1. And in this matrix multiplying, there's only one set of numbers to multiply. So this would be a 3 times 4, which is going to be 12. And then this is green and blue, and here's our green and here's our blue. So that would be 3 times 2, which would be 6. And then this is orange and purple. So orange and purple would be -4 times 4 is going to be -16. And then this is orange and blue, -4 times +2 is a -8. And so that's what you're going to fit into your 2 by 2 matrix? Right? It is asking us, can we multiply P and Q? Well, I don't know. What is the size of P? Well, 2 rows and 2 columns, so it's a 2 by 2. And column or matrix Q is a 2 by 1. And since these are the same, yes, it is defined, and our answer is going to be a 2 by 1. 2 by 1 looks like this. Okay, so we are going to use the rows in the first matrix and the columns in the second matrix. Well, we have more than one element in each part, so this is going to take a little bit more thought. Oh, let me do colors here again. So here's row 1, here's row 2, and here's column 1. All right, so we're going to put the blue and the orange together to get the first number. So, but there's 2 numbers in the blue, right? And there's 2 numbers in the orange. So what you're going to do, you're going to take the first number in the row and multiply it to the first number in the column. Then we're always going to add. Then we're going to take the second number in the row and multiply it to the second number in the column. And we are going to do that math. And once you multiply those 2 groups together and then add them, then that answer is what's going to go into your answer. So here is green and orange. So the first number in green is -1. The first number in orange is -5. Then we're going to add. The second number in green is -2. The second number in orange is +1. So that's 5 minus 2, which is 3, which is 3. And if you can do that rule, you're set to go. Right? There's nothing else basically to learn. They just tend to get a little bit more and more. So we do an R and S. R is a 1 by 3. S is a 3 by 2. So yes, we can do it, and our answer is a 1 by 2. And a 1 by 2 looks like this. So we're going to do the rows in the first column, or first matrix, and the columns in the second matrix. So in this one, we're going to do orange and yellow, but orange has 3 numbers. Yellow has 3 numbers. So we're going to multiply first to first, second to second, third to third. So 3 times 2 plus 3 times 0, plus -4 times 4. Do the math. And that's going to be 6 plus 0 minus 16 is -10. So -10 goes right there. Then we're going to do orange and green. So the first in orange is 3. The first in green is 2. Plus the second in orange is 3. The second in green is 4. Plus then -4 times -2. Do the math. There you go. That's your answer. Okay. And hopefully by now, you're getting a pretty good idea of what to do. But then they're going to kind of change it on you, okay? So the first question is, what is PQ? So the P is the first matrix and Q is the second matrix. Well, luckily on this, they're all 2 by 2s, right? So if I do a 2 by 2 and a 2 by 2, well, those are going to cancel out, and my answer is going to be a 2 by 2. So PQ. Green yellow. Hopefully these colors help for the ones that just need a little bit more push. Okay. So we're going to do 7 times 2 plus negative 5 times negative 2, 14, 10, 24. I'm going to make that line because we have this problem to do also. So I want to give myself enough room. So this number is 24. Then green and blue. So green and blue. I'm doing these fairly fast and without a calculator, so if you check me and I'm wrong, let me know. Negative 5 times 2 plus negative 6 times negative 2, negative 10 plus 12 is 2. Yellow and blue, negative 5, negative 9, negative 6, 3, 45 minus 18, 27? Yeah. Okay, so that is your answer for PQ. For PQ right there. Well, then it's like, what's QP? And, you know, for everything else, if 2 times 3 is 6, then 3 times 2 is 6, right? But not necessarily on a matrix. So what we're going to have to do, I'm going to get some room here, because this little bitty screen does not give me a lot of room to write. And what you need to do is write your Q matrix first, and then your P matrix second. And again, we're going to get a 2 by 2 because all of these are 2 by 2s. So I'm going to do this without colors this time. So 2 and 7 is 14. Negative 9 and negative 5 is positive 45 equals 59. Then 2 and negative 5 is negative 10. Negative 9 and negative 6 is 54. So that's 44. So I've done all of row 1. Now we're going to do row 2. Negative 2 and 7 is negative 14. 3 and negative 5 is negative 15. Negative 29. And I've done all of column 1. And then negative 2 and 5 is 10. 3 and negative 6 is negative 18. Negative 8. So this is my answer to QP, which is totally different than the answer to PQ. So they are not commutative, so you need to do both of them to be able to get the question right. Last one. What are GE and ED? Excuse me. Make sure I give myself some space. I'm going to try to speed up because I only have 1 minute 7 seconds left on my time. This is a 2 by 3. This is a 3 by 2. So yes, I can do it, and I would have a 2 by 2. Here we go. So negative 8 and 5 is negative 40. Negative 7 and 3 is 21. And that's 0. So negative 19. Negative 8 and 9 is negative 72. Negative 7 and 3 is negative 21. Negative 4 positive 8. Negative 93 plus 8 is negative 85. 15. Negative 3, 0. 12. And I'm about to run out of room. Go to the next video.